If an algebraic expression has parentheses in it, sometimes we need to simplify that piece of the expression before we can combine like terms or combine similar terms. Here's an example. If I ask you to simplify the expression 5 times 2x minus 8 minus 3, then we're going to need to use distribution, or the distributive property of a multiplication over addition, to simplify this piece of the expression before we can combine like terms or include the negative 3. Let's do that distribution. 5 times 2x is 5 times 2x minus 5 times 8. That's this piece, but I still have minus 3. Using the associative property of multiplication, I can rewrite this as 5 times 2 times x. Straight multiplication lets me simplify this to 40. And in any case, I need to do this multiplication before I do any subtraction. And finally, minus 3. Now, 5 times 2 is 10, so I have 10x minus 40 minus 3, minus 43. This is my final answer. If you were doing this question on an exam and I asked you to simplify 5 times 2x minus 8 minus 3, you wouldn't necessarily need to show every single little step. You can simply use the properties of real numbers that we've discussed in previous sections. So, for example, you might write this as 5 times 2x is 10x. 5 times 8 is 40. Bring down the minus. Don't forget the minus 3. And then combine the like terms, the similar terms. Same answer, one or two steps fewer than in the previous example. This would constitute adequate showing of work, because I can see from here that you understand that the 5 times 2 is what gives you the 10. The minus gets dropped down, and that 5 times 8 gives you the 40, and so on. Some expressions have more than one set of parentheses in them. And so we need to use distribution on this piece and on this piece, even though it may not be obvious here that that's what's happening. This one here, I get 5 times x is 5x, and then the minus, and 5 times 2 is 10. Now, on this one here, I'm going to be distributing this negative, and as in a previous video, I can think of this as 1 times 3x plus 4, because 1 times anything is itself. So here, instead of thinking of this as negative 3x plus 4, I can think of it as plus negative 1 times 3x and negative 1 times 4. So let's do that. Negative 1 times 3x is negative 3x, and negative 1 times plus 4 is minus 4, negative 4. Because I changed my negative 1 to addition of the opposite, or addition of a negative, I've used this minus, this negative sign here, in multiplying the negative 1 times the 3. That's this negative sign right here. So this plus sign is what goes between these two big pieces here, this piece and this piece. Now, finally, addition of a negative is the same as subtraction, so I can rewrite this as 5x minus 10 minus 3x and minus 4. And then look for like terms. Here I have 5 x's, and I'm going to spend 3 of them, so I have 2 x's left. And minus 10 minus 4 is minus 14. And this is my final answer. As before, this is not the only way to do a problem like this. There are always multiple approaches to algebraic problems. multiple approaches to how you might think through a problem. We do need to use distribution. I'm going to go ahead and do the same distribution here as I did before. That's going to give me 5x, 5 times x, minus 5 times 2. Here, I want to think about this as being negative everything that follows it. In other words, I want negative this stuff. Well, this stuff is 3x plus 4. So negative this stuff has to be negative 3x minus 4. There's an implied or invisible plus in front of the 3x. 3x is positive. When I take minus 3x, I get minus 3x. When I take negative this stuff, I get negative 3x and negative 4, or minus 3x minus 4. So that's another way to think through this problem. A third way is just to think of distributing the negative. Rather than thinking of distributing a negative 1, for example, you can simply think of distributing the negative sign itself. Minus 3x minus positive 4. Either way, you should end up with this. And then you can continue. The 5x minus 3x is 2x. Minus 10 minus 4 is minus 14. So again, I get the same answer as I did in this version.